So we take a look at 1.2. 1.2 talks about functions. So just real briefly, if we have two sets, so this is a relationship between one set called the domain and one set called the range. Our definition of a function says that every element in the domain has to be related to exactly one item. So notice G is related to only X. Y goes to W. Z goes to V. So if those were our only correspondents, then this would be a function because each one of these correspond to one item each. But because of X, this is not a function. Something in the domain is going to two different items. If one thing over here goes to two different items over here, then that makes it not a function. So this one is not a function. On the other hand, pieces on the right can be used multiple times or once. It doesn't matter as long as each piece on the left is only related to one item. So if we have this set, and let's do this. If we have this correspondence, this is a function because this goes to one thing. This goes to one thing. This goes to one thing. So if that goes to one thing, and that does, it is a function. It doesn't matter that the 3 on the right side is related to two different things. As long as each piece of the domain is only used once, it is a function. All right. Then they give us, instead of the diagram, they give us a set of ordered pairs. So to list the domain, that's all of the X values. So since we have individual points, we list individual X's. And the way we do that is we put it in braces. An interval, if I did something like this or did parentheses, that would mean every real number from here to here. But if I'm listing individual values, we put those in braces. So we have 1 is an X value, 28 is an X value, 40 is an X value, 1, well, we've already listed 1, so we don't have to write it again because we're just telling which values, not how many times they're used. And then 46 is part of the domain. That's fine to leave it like that. I was going to say, or you could put them in order. Well, in this case, those are in order, so that's fine. And then for the range are all the Y values. So we have an 8 as a Y value, a -1, an 8 again, a 5, and a 5 again. So the unique Y values are 8, -1, and 5. We didn't have to list anything more than once. We just listed what values do we have in the Y place. So that's domain and range. And then it asks, is it a function? And on the test, I might say, what makes it not a function if it's not a function? So 8 is used here and here, but that's not a problem. 5 is used here and here. That's not a problem. The problem is here. A 1 goes to an 8. 1 also goes to a 5. So if an X value goes to two different Y's, it's not a function. It's still a relation, meaning that the two sets are related to each other, but not in the format we call a function. So anything in the domain going to two different items, not a function. Now this question has us interpret some function notation. So in function notation, if we have something like h of 5, the value on the inside is an input value, also known as our x value, and the answer to this is our output. In other words, when x is 5, what does that correspond to? So a graph is just a relationship, a connection between x values and y values. At different x values, how are they related to different y values? So for the x value 5, here this point has an x value of 5. That's related to a y value of negative 1. If we look at an h value of 7, or an x value of 7, when x is 7, here is an x value of 7, here's our point. So when x is 7, the corresponding y value is 3. So that's how we interpret that. Sometimes you might be told h of something is 2. What x corresponds to h being equal to 2? Well, if this is the x, that's the y. So we're asking ourselves, when y is 2, what x goes with that? So this point and this point have y values of 2, so those correspond to x being 6 and x being 8. So we would say x is 6 and x is 8 when our function equals 2. Now this one, it just asks us whether or not this is a function. And remember, when we have a graph, if we want to know whether or not it's a function, we use what's known as the vertical line test. If we draw a vertical line and it only touches the graph once, then that means at that particular x value, there's only one point. So if we put a vertical line here, for this x value, there's 1 point. For this x value here, there's 1 point. But we have a problem here. For this x value, and I'm just going to make one up, let's suppose right here x is 2. For this particular x value, there's a point here and a point here. So for example, this ordered pair, x might be 2 when y is 1, and down here, x might be 2 when y is 5. So if a vertical line touches more than 1 point, both of those points have the same x value. They're over the same amount. Over the same amount, hence the same x, but 2 different y's. So the same x with 2 different y's, not a function. So that's why that vertical line test works. Another topic we come across in section 2 is to determine what the domain is given function notation. So in function notation, we have this formula and we want to know the domain. The domain means what x values can we use. So let's start by looking at an example when we can use any x value. If we're given this function, x can be all real numbers. Well, why can x be all real numbers? Any number you pick, you can add 3 to it. Make up any number, and you can add 3 to it and get an answer. There's not a number in existence that you can't add 3 to. So then what about something that has a domain that's not all real numbers? How do we get a domain that maybe has some breaks in it? Well, one thing that we're going to come across is when we have fractions, we can't divide by 0. Dividing by 0 is undefined. So any number that makes our denominator, what's our denominator? It's x to the 4th. Anything that makes our denominator 0 is going to make us undefined. Well, in this case, that equation is true. The denominator is 0 whenever x is 0. So now we ask ourselves, well, what does that mean? Does that mean 0 is the domain? Well, no, 0 is not the domain. 0 is the number that we're not allowed to use. If we put 0 into our function, we get 1 plus 2 over 0. We can't have 2 over 0. That is the number that makes it undefined. In this case, 0 is the only number that makes it undefined. So our domain in words is all real numbers except x cannot be 0. As an interval, that means we can start out way to the left at negative infinity. Imagine this is a number line and we're describing every x that's okay. So we can go from negative infinity, and the first number we get to that we're not allowed to use is 0. So when we get to 0, we don't include it, so we put a parenthesis. And then if we were on the far right side, way out here at infinity, we can use anything until we get to 0. When we get to 0, we can't use that. So often we would put either an open circle there, or we'd put a bracket, or parenthesis that way and a parenthesis that way, indicating 0 is not included. So anything in this interval with anything in that interval is okay to use. We just can't use 0. Just another quick example. If we had the function 3 over x minus 4, x could not be 4. Because if we put a 4 in, 4 minus 4 is 0, that's not allowed. So our domain would be from negative infinity to 4, but we can't use 4. And then if we go over that little gap, we would go close to 4 to positive infinity. And that would be our domain. That would include every real number that doesn't make that 0. This is the number that does make it 0. These are all the numbers that don't make that 0. And then the last question that I'm going to go over is this one. It asks us to look at a graph and determine the domain and range. So remember that the domain is the x direction. So the x direction is left and right. So we go forever to the left and we go forever to the right. That's what the arrows mean. And we touch every single x value in between here. So everything from negative infinity to positive infinity. If this listed individual values, we would have to put those in braces. Or if we had a hole here and a hole here, then we would have to write that as different intervals. For example, this negative infinity, and we would get really close to negative 1, but there's not a point there. And then from between negative 1 and 3, we include those points, just not the edges. And then from 3 to infinity, we would include all of that. But we would have to break it up because negative 1 is not included and 3 is not included. So that's how we could write an interval or intervals that describe everything except those points. But since we don't have holes in ours, we just have that domain. Now what about the range? The range is the y value, so how far up and how far down. So what is the y value here? Well, that y value is 3. What's the y value here? Well, that y value is also 3. 3, 3. Everywhere we touch on that graph, the y value is 3. So we only have one value in our range. So we don't list an interval. We put it in braces, and we tell what that number is. So the y value that we have is 3. So that's our range. Also, if you were to write that equation for that, the equation for that is y equals 3. Because at any x you go to, the y value is always 3. So that's domain and range. This one is a function. It tells us, but it's a function because the vertical line test only touches one point everywhere we put our vertical line. Our graph is only being touched once with every vertical line.